Okay, so this is the key for fall 2021. I don't know where this word went. So yeah, so we're gonna go ahead and solve this sucker. We'll work this step by step, and I'll just kind of talk you through it. Okay, so the first thing we're gonna do here is this problem right here. We've got a 50 kilogram crate right here, 50 kilograms. Is attached to a trolley beam system shown, knowing that A is 1.5 meters. I don't know why they made that an A instead of just wrote 1.5 on there. Determine the tension in cable CD, so we want this. And we want the reaction at B. Okay, so we're going to start by drawing a free body diagram of A. Okay, so free body diagram. Sorry, I got distracted there. Hopefully my narrative is not too far thrown off. I'm going to use a straight edge here because why not? Oh, come on. Straight edge slid on me. Okay, so we're going to have a little thing there. Here's the point B. And then we've got a point up here, which unfortunately is not on the, it's not where we'd like it to be. Okay, so this is going to be, what are we calling that? CD, I think? Yeah, we'll call that CD. We'll note that this angle is 35 degrees because there's nothing wrong with that 55 degrees, but it's not on it's not going to be on our free body diagram, so I'm going to use the 35. You could use the 55 if you wanted, it's totally fine. Okay, let's get some measurements on here. Oh wait, and we need some forces, right? So there's a force right here. That's B in the X. And here's B in the Y. Okay, this distance right here is what, 0.4 meters. And then we've got this 50 kilogram weight. So, let's see. Weight equals mass times gravity. So I'm just going to multiply that by 9.81. And that's 490.5 newtons. Okay, and that's going to have a distance of like that and like that. Okay, so this is going to be what, 1.5 meters? Oh, we've got one last distance, don't we? We need this distance right here. Okay, which I'm going to get by doing, let's see, we're given this side, we need the opposite of that 55. So I'll do tangent of 55 degrees equals the opposite over the adjacent, which is 1.4 meters. So the opposite equals, we plug it into our calculator, 1.9994 meters. That's horrible. By the way, it should just give me anyway. So that distance right here to C, let's do a little dotted line here, like that. Okay, so here we go. Oh, that should be dotted. Give me my little eraser here. Sound effects. All right, so that distance is 1.994 meters. All right, so that's our free body diagram. Let's see. So I'm going to stare at this and try to figure out which one I should solve for. So I'm looking for, so these are my three unknowns, BY, BX, and CD. If I sum forces in the X direction, I've got two unknowns, CD and BY. Okay, so I don't want to do that first. If I sum in the Y direction, I've got two unknowns, CD and BY. So I'm going to do moments, and I'm going to do moments around point B. Okay, just because that's going to be my easiest, or at least the equation that I can solve right off the bat. So sum of the moments around the point B equals 0. Okay, so let's see here. CD I'm going to need to break apart, right? So I'm going to break it into CD going this way and CD going this way. And it looks like I didn't draw that angle on there yet. So here's my 35 degrees. Okay, so we'll note just that this is CD cosine of 35 degrees. This is CD sine of 35 degrees. Okay, so let's do our moments, and we'll start with CD. So we got CD cosine 35 degrees. Okay, and we'd kind of like walk that one over here. Okay, noting that this is our moment arm right there, so that's 0.4 meters. Okay, and that's going to cause things to spin this way around point B. So that's going to be clockwise, so that's going to get a negative sign. Okay, and then I'm going to have CD sine of 35 degrees. Okay, that force. Okay. And so we're going to walk it back, right? It's actually occurring at C, even though I drew it as if it was occurring over here. Okay, but clearly it's not. And so what we're going to do is we're going to back it down to about right in here. And here's my distance. My perpendicular distance is right here. Okay, and that distance is 1.9994 meters. Okay, and we'll note that it's causing things to spin this way around point B. Okay, so that is also clockwise, so it's going to get a negative sign. Okay, we're not worried about either of those B forces because they're going right through the point B. But I am worried about this 490.5 meters. So I'm going to go, let's see, so that's going to, well, the perpendicular distance there is fairly straightforward because, you know, the force is, it's like right there. So that's going to be 1.5 meters. And the direction, well, let's just write my force here, 490.5 newtons. Okay, and its distance is 1.5 meters. I don't know why we've changed colors at this point. And this 490.5 is causing it to spin that way. Okay, so that will be counterclockwise, so that'll get a plus sign. Okay, and that's going to equal 0. So those are all the forces that create a moment. Okay, so if we do the algebra here, we're going to end up with CD equals 498.99 newtons. Okay, so that's good. So that's our first answer. Although I guess we're gonna report it with 3 sig figs because that is the request up here. Okay, so sum of the forces in the x direction now equals 0. Sum of the forces in the y direction equals 0. Which one of these do we want to do first? In the y direction now, my only unknown is by. In the x direction, my only unknown is bx. So we can do either one. It doesn't really matter. Okay, so let's just start with x then. Okay, so I got bx, which is my unknown. Okay, plus cd, this one right here. I need the x component of that. So that's going to be cd cosine of 35 degrees. Okay, is that my only x component? That is my only x component. Okay, so I'm just going to go ahead and plug this right in, CD, right down there, through that sigma, down for CD, plus 498.99 newtons, okay, times cosine of 35 degrees, so equals 0. So bx equals negative 408.75 newtons, like that. And sum of f in the y. Okay, sum of f in the y. So let's see, what do we have in the y direction? We've got 490. We've got the y component of CD, and we've got by. Okay, so I'm going to start with by because that's what I'm looking for. It doesn't really matter, of course. Let's add the z component of CD plus, the y component, CD sine of 35 degrees minus 490.5 newtons equals 0. Okay, so again, I'm going to plug that CD in over here. I'm going to say by plus, what is that CD? Oh, 498.99 newtons times the sine of 35 degrees minus 490 newtons equals 0. So by equals 204.29 newtons. Like that. Okay, and then let's see, I would report this because I want 3 sig figs, so maybe I'm going to put them all over here, bx and by. Okay, ideally I think you would combine bx and by into b with an angle, but I didn't do that here. So this is going to be, CD is going to be 499 newtons, okay, and it's got an angle of 35 degrees. Bx is 409 newtons, and it's going that way. And by is 204 newtons, and it's going up. Okay, so there you go. That's how you solve it. Okay, so as far as points are concerned, let's focus on this moment equation. That's the biggest and the hardest and the most important equation on this whole thing. So we're going to go for, basically each term here is going to be worth 2, right? Except for this 0, which is going to be worth 1. So it's the force with the associated sign. Okay, those are all going to be worth 1. And then the moment arms are going to be 1, 1, and 1. Okay, so that's 7 points right there. Okay, and that leaves 4 points for each of the easier equations. Okay, probably not as much work in these. So we're going to go plus 1. This one's easy. Plus 1, plus 1, and then you got the equal sign over there, which is awfully nice. Okay, obviously the signs matter and that sort of thing. Then over here we're going to go plus 1, and then plus 1 for getting that equal sign on the other side. And then we've got a floating point, which I guess we'll just make that point. This is the sig figs and I guess presentation of answer point. Presentation of answer. Okay, so basically, does it look something like this? Okay, you obviously could have taken bx and by and made it a single. You could have just said b. I guess CD gets one of these. I guess the way that I've drawn them, they're kind of like that. But anyway, you could have said b equals, what is this, 409 and 204. So this is probably a 30-degree angle. You could have done it and given yourself, an angle like this of approximately 30 degrees. I haven't done the math on that. And then given them the magnitude right here if you wanted to. But basically, as long as your answer is presented in some kind of way that fits with the format that, we have done in this class, I'll be okay with that. And that'll be the last point. Okay, so, even if your answer is wrong. So, okay, so let's go over here, and we are going to do the next problem. Using the method of sections, determine the force of members BD. I guess let's get some ugly color here so I can see it. So BD, CD, and CE in the truss below. Okay, so what that's telling me, indicate whether the member is in tension or compression. This is an older version of this test. I'm supposed to have spaces down here for you to write that in. Well, I'll just write it in myself. Okay, so now in a problem like this, I know I'm going to cut it right here. Okay, and it's just a question of which one I'm going to do the free body diagram of, right? And so the easier way to do this, and maybe I'll solve this both ways, but it's going to be easier to do a free body diagram of this side because then I don't have to worry about getting the reactions at F and E. Okay, but it's up to you. Okay, I guess I'll solve this both ways, so that'll make this video a little longer. My battery's running out, so I'll have to plug it in and come back to this. My battery's not really long enough to work at the same time that I do this. So let's do that free body diagram of that thing that I just drew. Okay, so I'm going to pull out my trusty ruler and pause it for a second so you won't have to listen to me draw. Okay, so there it is, more or less, right? And so here's the points, A, B, C. And I know I've got this 650 Newton force, and it's kind of cruising off this way. All right, 650 Newtons. Okay, and so I'm going to assume that I've got these forces here. This is going to be BD. I'm going to make it in compression. This is going to be CD. I'm going to assume compression. And this is going to be CE. I'm going to assume compression, CE. Okay. Now, an annoying thing about this, of course, is I've got this 650 Newton force over here. I'm going to go ahead and do this over here. You can do the trig on this if you wanted to. I find that that's like, we've got this 12 and this 5. So the easiest thing to do here is, well, 5 squared is 25. 12 squared is 144. Add them up, you get 169. Square root of 169 is 13. Okay? So I know that, I know the ratio of these sides. Like, this side, that force, I'll do it in blue, since this is in blue. Okay, this side of this triangle is going to be 12/13 of this side. So that's going to be 600 newtons. Okay, and this side of this triangle, That's going to be 5/13 of this force. Okay, so 5 divided by 13, or 650 by 13 times 5, and you get 250 newtons. Okay, and that's up to you. You can do the trig if you wanted to. If you do the trig, the opposite over the adjacent, you'll get a number right here, which is 22.620 degrees. And then you would do, and then you would use the cosine of that times 650 to get 600 here. And you would use the sine of 22.620 to get this number right here. Okay, either way you want to do it. Okay, so let's go over here. And what I'm going to do is I'm going to go ahead and put those on here because that's going to make my life easier. So let's do this. I've got, this is a 600 Newton force. That seems excessively large, but whatever. The arrow. And then we'll do one here. So this one's 250 newtons. Okay. Now, for simplicity, I could even just go ahead and erase this one if I wanted to, since I've now replaced it with two forces that, kind of fill its role, right? Okay. And if I wanted to, in fact, this might be a good policy if you had the proper tools for it, is to maybe make your forces a different color from the frame itself. Maybe I'll start doing that regular, like that. Okay, so again, we have to figure out what is going to be the easiest here. And let's see here. If I have some forces in the y direction, or sorry, the x direction, this one's got an x component, this one's got an x component, that one's got an x component. So I've got three unknowns in the x direction. So we're not going to do x first. What if we do the y direction? Well, we've got CD is unknown in the y direction, 600 is unknown in the y direction. So that's pretty easy. So let's start there. Okay. It looks like the moment equation could be easy too, and obviously depends on where you do it. But let's start with those. Okay, so let's do sum of the forces in the y direction equals 0. Okay, I've got a negative 600 newtons. Okay, now I need to subtract that CD. Okay, and again, I think this is easier if you notice this is a 3, 4, 5 triangle. Most of you all will not prefer that. Most of you will get this angle. So if you do that, so if we go over here, let's get that angle. Okay, 1.6 over 1.2 for this angle right here. So we do the inverse tangent of 1.6 over 1.2. And you're going to get, I think, 53.13 degrees. Okay, so 53.13 degrees. So let's go over here. This is 53.130 degrees. Okay, so minus CD sine of 53.130 degrees equals 0. Okay, that's very tractable, like easy problem. We'll get CD equals a negative number, 750.00 newtons. Okay, again, keeping 5 sig figs. Okay, so that's cool. That's solvable. Okay, that doesn't really help much with the x direction because I'm still going to have this CE here and this BD, still two unknowns. Well, it does help in the x direction, but that's not the next one I'm going to solve. So I'm going to sum forces, So I'm going to do the moments. And the key here, as always, is to pick that beautiful point. That's going to make it easy. So we're going to pick this point C right here, because CD and CE both go around that location. Go right through that location, so they have no moment. Okay, so I've got BD times its moment arm. Okay, again, I'm going to do this just like I did the last one. So I'm going to kind of slide BD over here. And then note that its perpendicular distance is right here. Well, if I can draw perpendicular anyway. So that distance was 1.6 meters. Okay, so that's 1.6 meters. And then that direction is like this, around C, so that is counterclockwise. So that gets a positive sign. Okay, so then we're going to do A. So we've got AX and AY, or whatever that force is called. That's 650. We're going to do the X component of it and the Y component of it. So the 250 newtons. Okay, and note I'm going to take that 250 and I'm going to slide it back this way. And it's got the same moment arm as BD, right? So it's also going to be 1.6 meters. and it's pointed in the same direction, so it's going to cause the same rotation. Okay, the 600 newtons, on the other hand, let's go ahead and we'll get another 600 newtons. Okay, and it's going downwards. But let's see, so we're going to slide it over to about right here so that we can get a perpendicular distance, which is like right here. Okay, so its perpendicular distance is basically the distance from A to B, which is 1.2 meters. Okay, and it's causing things to spin like that around C. So we're going to call that counterclockwise. So we'll do a plus equals 0. So I've got 3 counterclockwise forces. So one of these is going to be wrong. So BD is going to end up being negative, right? So if we solve this, we end up with BD equals negative 700.00 newtons. Okay? So now let's go ahead and solve the last bit of this. And so that's going to be the sum of the forces in the x direction. Sum of the forces in the x direction equals 0. Okay, and I want to ignore these answers for now. I want to pretend I don't know that those are negative signs. I just want to look at my picture. Okay, so sum of the forces in the x direction. Let's see, we've got a negative 250. I've got negative BD. I've got minus CD in the x, minus CD cosine of 53.130 degrees. And I've got minus CD equals 0. Okay, so there should be 4 terms. Wait, sorry, minus CE, excuse me. So 4x forces. Okay, so we're going to go negative 250. For BD, I'm going to plug this in, minus a negative 700 newtons, minus CD at negative 750.00 newtons, cosine 53.130 degrees, minus CE equals 0. Okay, so if we solve this, if we put this in our calculator or whatever, we're going to get CE equals 900.00 newtons. Okay. So, so that means we would go over here where, my stuff is, and I would report all the answers as BD, CD, and CE. And I assumed compression on all of these, so everywhere we have a negative sign, that's going to become a tension. And so BD is going to be 3 sig figs, 700 newtons, and that's a negative, so that's going to be in tension. CD is 750 newtons. That's going to be in tension because those were negative signs. And then CE equals 900 newtons in compression. Okay? Okay, to grade this thing is worth, what was it? Oh, come on, give me a hand here. This thing is worth 15 points. So, obviously the interpretation of your answers over here, tension or compression, that's 1, that's 1, and that's 1. And then beyond that, so that leaves us 12 points. So basically it's 4 points in equation. So we'll put 4 points on this equation, 4 points on this equation, 4 points on this equation. Okay, and so, so we'll have to adjust it accordingly. Okay, so that's that. I'm going to go ahead and erase this, and I'm going to redo this in the case where you drew the other free body diagram. So you drew the left-hand side. Okay, so let's go ahead and erase this. Oh, no, we need to erase with this one right here. Okay. And so what we're going to do is we're going to solve this again. I'm doing this without a, I'm doing this live. I don't have my key in front of me. So this will be how to do it if instead of, cutting it, so we're going to cut it here, here, and here again, but instead we're going to draw our free body diagram here, right? So we're going to kind of, yoink, and then we're going to go yoink like that. Okay, so we're only going to draw, we're basically going to solve that half. The problem with that half, of course, is we've got E and F in there, and E and F are external, so we would need to get the reactions first. So we're going to draw the free body diagram of the hole in order to get the reactions. Okay, so the hole, and we're not going to get really into the details here because there's really no need for that. I am going to use my my trusty ruler here because I like that kind of stuff. Right, and this is not going to be a great drawing, but it doesn't really matter, right? And so I'm going to draw the forces. I'm not even going to bother drawing the interior beams because I don't really care, right? So here we go. So we got 600 going down, and we got 250 going this way, right? So we solved that last time. So this is going to be 250 newtons going this way, and this is going to be 600 newtons going down. Okay, now I've got force E because that's a roller. And then I've got Fy, and I've got Fx. Okay, so the first thing I need to do is I need to solve for E, F of x, and F of y. Okay, so in the vertical, that's no good. In the horizontal, we've only got one unknown. So we'll go ahead and do that. So we'll go F of x minus 250 newtons equals 0. So F of x equals 250 newtons. Okay, the vertical is still hard because E and F of y are two unknowns. So we're going to go ahead and sum the moments, and we're going to sum them around this point right here, point F, because that's just going to be, a nice spot because both of those F forces go through the middle of that. So the 250 also goes through the middle of that, so that doesn't have a moment arm. So we're going to have this 600 newtons, and its moment arm is, let's see, it's going 1, 2, 3 of those. So 3.6 meters. And it's causing things to spin. It looks like it's going that way. So that's going to be counterclockwise. So we'll put a positive sign on that. Okay, it would be nice if I hadn't drawn that. But it's okay. Okay, so it's going, it's going counterclockwise. So it gets a positive sign. Sorry, thank you. And then I've got E, right? And E, okay, which if I kind of dot it up here, it's causing things to go this way. So that's clockwise. Okay, and its moment arm is from here to here. So that distance is 1.2 meters. Okay, so E, it looks like it's going to be 3 times as big as that 600 down. So it's going to be 1,800 newtons. Okay, let's go ahead and just box these in as we go. So now I can do the vertical because I don't have too many unknowns. So sum of the forces in the y direction equals 0. And let's see, we've got negative 600 newtons plus E, 1,800 newtons plus Fy equals 0. So Fy is going to be negative 1,200, right? Negative 1,200 newtons. Okay. So now I'm going to do my free body diagram of just the right-hand side. This problem doing this side is a little bit of a space problem. That's okay. Okay, so I'm going to do free body diagram of the right-hand side. Okay, so that's going to look like, let's see. Now I'm going to start to care a little bit about getting this at least kind of a reasonable facsimile of reality, what we've got going on over there. Okay, and then I've got this going down this way. I've got this one right here. And give me an eraser right here. Okay. So now I've got, let's see. Okay, so I got this and this and this. And I'm going to go ahead and do my forces in blue. So let's see. Fy, let's see, that's negative 1,200. So I've got 1,200 down right here. I've got Fx is 250 in this direction. And I've got E right here is 1,800 newtons. Okay. So then I'm going to assume compression for BD. CD and CE. Okay, so I'm going to zoom in here. And let's see, in the Y direction, we've only got one unknown, so that's good. So let's go ahead and start there. I mean, the X direction, we've got 3 unknowns, right? So that's no good. But let's go ahead and do the Y direction because we can do that. Sum of the forces into Y equals 0. I've got negative 1200, so that's this one. I've got plus 1800. And then I got CD. And then I've got plus CD times the, that's what, sine of, I believe that angle is 53.130. Okay, let's, 53.130 degrees equals 0. And so if we do the algebra, then CD equals 750.00, and that is a negative sign. Okay, and that's newtons. Okay, so that's going to be tension. Okay, so then we still can't do X because there's 2 unknowns. So let's do a moment. Let's do the sum of the moments around, what's the best spot? We can either go out here to, like, we can dot this out and we can do moments around C. I don't really like to do it off the what do you call it, if I can avoid it. So instead I'm going to do it up here at point B. I think that's point B, right? Oh, that's point D. Oh, sorry, this will be D. Okay, right, okay. So we're going to do it right there. Sum of the moments around point D equals 0. So that's going to eliminate, for our moment equation, that's going to eliminate BD because it goes right through the middle of it, CD because it goes through the middle of it, this 1800 because it goes through the middle of it, and this 250 because it goes through the middle of it. So ultimately, this is not that difficult an equation because almost all of these forces go through the middle of it. So I've got CE times its moment arm. So CE, we can kind of like, let me do this in blue maybe, kind of like march it over here, and then here's its moment arm right there, which I believe is 1.6. Yes, 1.6. Okay, so multiply that by 1.6 meters. Okay, and notice that's causing it to spin this way around point D, so it's counterclockwise. And then the only thing that's working against that is this 1200, or the only other force is that 1200. So we've got 1200 newtons. And it's got a moment arm of whatever that distance is, which I believe is 1.2 meters. Okay, and that's causing things to spin that way, so that's going to be a negative sign. So that equals 0. So CE then equals 3/4 of 1200, which I believe is 900. And that is 900 on the nose. I'll go ahead and give it 2 sig figs like that. That's a positive. So that means that that one's in compression. All right. So now we're ready for the X equation. Unfortunately, we don't have a lot of room here, but I'll just go ahead and work off the page. Sum of the forces in the X direction equals 0. So let's say we've got BD plus CD cosine of 53.130 plus CE plus 250 equals 0. And somehow it wouldn't surprise me if that's, well, I don't know. Anyway, so let's go ahead and we need to plug in. We're solving for BD. CD is negative 750 cosine 53.130 degrees plus CE, which is going to be 900 newtons plus 250 newtons equals 0. Okay, so if we plug all that in, we get BD equals, is it like a negative 700.00 newtons. Okay, so I believe that, well, it certainly should match. Oh, look, here's my spaces. Look at that. All right, so it just printed all weird. I was just thinking like, oh, look at those spaces. All right, so CD is 750 point, and that's a negative sign, so tension, because I assume they were all in compression. So CE is 900, and that is in compression. and BD is 700, and that is in tension. And I believe that should match what we got when we did it the other way. Okay, I will grade this basically the same way based on these equations, right? Obviously, if you did this half, it just has the added disadvantage that you had to get the reactions first. All right, so we're going to scroll over here, and we're going to do this one up here, okay? And just real quick, let me erase this because this is going to be in the way. All right, so I'm going to do this twice, much like the last problem, but I'm going to do this one time that I'm going to call quick, and then I'm going to do it one time that I call probably what I expected you guys to do. So I put this sheet of paper on here twice. Okay, so here's the quick way. And what I'm going to do is I'm going to zoom all the way in on it. And I'm just going to start working it. Now, this is a little bit wonky because normally what you would do, even if you're doing the quick way, is you would solve for the reactions here. I'm actually even going to skip that step, and we're just going to see how far we get before we get there. And what I'm going to do is I've kind of rehearsed this idea in my head a little bit. Is I'm just going to start somewhere, and I'm just going to zoom all the way in and just think about the forces on it. And what I'm going to try to do is I'm going to try to keep the forces color-coded. The horizontal ones are going to be in blue, and the vertical ones we'll do in red, and the diagonals we'll do in black. Now, before I do this quick way, I want you to remember this. This is a 3, 4, 5 triangle. 3, 4, 5. Which means if I have a force, suppose I end up with a force on a diagonal and it's 1,000 here. Okay, well this side right here is going to be 3/5 of that because it's 3 over 5. So this side's going to be 600. This side right here is going to be 4/5 of that, so this side will be 800. Okay, so I'm going to make use of that. Okay, I could go and get this angle and do all this that I'm about to do with angles, but I'm not going to do that because when trying to do it the quick way, you don't want to. I should have just left that there, shouldn't I have? Okay, so I'm just going to leave that there for you. This is going to be 5, 4, 3. Okay, and so this is going to be, say, as an example, the forces could be 1,000, 600, 800. Obviously, it is going to be different numbers, but that ratio is going to hold because all of these triangles are 3, 4, 5. Okay, so let's start, and I'm going to zoom in here to A. Right, I'm not even going to draw the free body diagram. Right, I'm just going to mentally imagine. Okay, the forces I have on this one. Okay, so the vertical forces I have on this. Well, I've only got one vertical force. So for that one vertical force to add up to 0, that force has to be 0, which means that this whole member right here, this is 0. If I sum forces in the vertical on A, well, there's no external force on A, and there's no other forces on A in the vertical, so that one has to be 0. Okay, in the horizontal, if I sum forces in the X, well, there's only one force coming in it, and that's A, whatever is going along this member, AB, and there's no other forces, so it also is going to have to be a 0. So this is also a 0 force member. Okay, actually, let's do blue on that, right? Because I said we were going to make these. Okay, so there you go. All right, so moving on. Let's go over here to this one. All right, so I got 1,200 coming in from the right. From the right. And I've got, the only other force that happens that has any component in the X direction is this one right here. Okay. All right, so if I do the X direction, then this one's going to have to be 1,200 newtons, right? Because it has to match this one, since this one is a 0. All right? And now we're going to do the verticals. Okay? So if I know that that's 1,200, well, then this one, well, what is that one going to be? Well, in this case, this is actually pretty straightforward, or straightforward-ish. Sorry, I drew that in the wrong direction because it has to, go in the same direction as this one, right? Those are the components of this force, right? I know this is a 3, 4, 5 triangle. So here's my triangle. right? We remember that our, let's see, our verticals are 3. These are 4s, okay? And this is 5, okay? So this side, that 1200, is going to be 4/5 of the diagonal. So we take that 1200, we multiply by 5 over 4, and we're going to get 1600. 1500? 1500. 5 over 4, yeah, 1500, okay? So we're going to get 1500 right here, okay? Now to get this side, I can either do 3/4 of this side, or I can do 3/5 of this side. Either way, I'm going to get 900 newtons. Okay, cool. So what I can do now is I can take those numbers and I can go over here. And basically what I'm going to do is I'm going to draw that in exactly the opposite order, right? So this is 1500 newtons, and this is 900 newtons going this way, and this is 1200 newtons going this way. Okay, so let's zoom out. Let's see what we know now. Oh, well, we're getting somewhere. Okay, we still haven't finished B though. So here we are. We're staring at this, and now let's go ahead and sum forces in the y direction. Well, the only force we have in the y direction is this 900, and then we've got B, whatever's in this beam right here, and it's going to have to be going downwards. Okay. So and it's going to have to be 900 newtons. Okay. So now we're going to scroll down, and I'm going to say, okay, well, if that's 900 newtons, well, then this one right here, that one's also 900 newtons. Okay? All right, so let's see. Well, we could probably work this problem at any location. I don't like this location, though, because it's got too many unknowns. Right? I've got 2 in the x. Those both have x components. Sorry, x components will be blue. Okay? We've got this component and that component, which we don't know in the x. And in the y, I don't know, this one has a y component and this one has a y component. So I've got too many unknowns over here, so I'm not going to do that. Let's go over here. Okay, well, let's see. I've got an unknown in the x and an unknown in the y. Let's do it. Okay, so this one is the unknown in the x direction. All right, and the only other thing that's going in the x direction is this guy right here. It's 1200 to the left, so this one's going to have to equal that and be 1200 to the right. Okay, now if I go sum forces in the y direction, well, this is a big fat 0. This is 900 down. So to make this one equal to 0, this one's going to have to be 900 up. Okay? So now I've done x and y on point C. So let's go over here, and we'll do it on point D. Oh, wait, sorry, we didn't make this 1200 going this way. Right? I need to go down here and make this, we got 900 going down right here. All right, cool. All right, so let's go over here and let's see what we've got. We've got 1200 and 12, we've got 2 1200s going to the left, and I've got one more blue that I don't know, right? So I now know this one. So let's solve for this blue right here. And let's see what we got. So if we've got 1200 to the left and 1200 to the left, that means I need 2400 going this way. Right? Okay. So once I got 2400 going that way, well, now I know I'm going to get a nice little diagonal here, and I've got a little red bit going this way, right? So again, remember, 3, 4, 5 triangle. Okay, so I think the 3 was on the vertical, this is the 4, and this is the 5. Okay, we can check that real quick. The 3, the 4, the 5, yes. Okay, so this side right here is going to be 5/4 of that side. So we take that 2400, we divide by 4, we'll get 600, we'll multiply by 5, and we'll get 3000 newtons. Okay, and then that will also enable us to get this red bit right here, to get that vertical, right? Because we'll just say, okay, well, this side here is 3/5 of that side. Okay, so we'll take that 3000, divide by 5, and get 600, multiply times 3, and we're going to get 1800 newtons. Okay, so now I've got 1800 up, I've got 900 up, and this is the only way that I can balance it. So I'm going to balance that with a with a 2700 down in red, right? Assuming that this thing will unfreeze so that I can do that. Okay, so this is 2700 newtons in red. Okay, so now go down here and I'm going to have 2700 newtons in red. Okay, and then we're going to go over here and I want to copy this particular guy down. So this is what, 3000 newtons. Okay, so this is going to be 2400 newtons and 1800 newtons. Okay, so we can do any one of these that we want to do. I'm going to go down here to this one, and I'll note that E has a roller right here, right? So it's only going to have an upward force, and I don't know what that force is, although I kind of do, don't I? Right, because that's the only unknown vertical force. So I've got 900 going down, 1800 going down, so this is 2700 newtons going up. That's cool. I just solved for the external force. Right, and then for my horizontal, well, this is my only horizontal at this location. So this one's going to have to opposite that one, right? And it's going to have to go to the left by 2400, right? So let's scroll over here. So that means for that to happen, this one has to be 2400 right here, right? Which means that my external forces, f of x has to be 2400. So there's an external force of 2400 right here. And then my external force downwards needs to be 2700 newtons to account for this. Okay, so now that we've done all that, how do we check our work, right? Because, well, we're going to check the externals. This is unusual. You wouldn't normally do this way. But let's check my externals. Okay, so in the x direction, I've got 1200, 1200, 2400. Okay, those all add up to 0. In the y direction, I've got 2700 up and 2700 down, so those add up to 0. In the if I do a moment, let's imagine I did moment around point F, right? I've got 1200 times 3, and I've got 1200 times 6. Okay, so I've got 1200 times 3, 1200 times 6, and those are both going counterclockwise around point F. Okay, minus 2700 times 4. Okay, and that should equal 0 if we've got what do you call that? Equilibrium. So 2700 times 4. Okay, and then we'll take that number and we'll divide it by 9, and we get 1200. So this checks out. Okay, so that's how we know we did it right. And then what we would do is we just go back in here and we would say, well, AB is a 0 force 0, AC is 0. BC is 1500 in compression. This is 900 newtons in tension. This is 1200 newtons in tension. This is 900 newtons in compression. This is 3000 newtons in compression. This is 2700 newtons in tension. And this is 2400 newtons in tension. Okay, and those would be your answers, right? You would just go fill them out in that little chart. Okay, so that's the fast way to do it. It's not really the way that I expected you would ultimately do this, okay? But you could do it that way. By the way, this also would work cleaner if you stepped in and just did got the reactions right off the bat. If you get the reactions right off the bat, then what will happen is the way you'll check your work is on the last joint. You'll just check it. But we're going to do that way next, where on the last joint. I can't remember which one's going to end up being the last joint. I guess it could be a few different, depends on how you do it. So I'm going to scroll away from this one and pretend we don't know any of that. And what we're going to do is we're going to go down here, and we're going to do this again. Okay, determine the force in each member of the truss shown. Okay, so what we're going to do is we're just going to free body diagram this sucker to death. Okay, free body diagram of the whole, because we want to get those reaction forces right off the bat. Okay, and I'm actually going to be fairly quick with these because When you have to do tons of these, it can be helpful to just be quick. Okay, so we've got 1,200 newtons here. We've got 1,200 newtons here. Okay, this is 3 meters. This is 3 meters. Okay, I've got forces here. I've got, oh, well, I guess we've been doing my forces in a different color. So let's do my forces in blue. We'll try to make that kind of a standard thing for this problem. Should help us see what's going on. So we've got Fy, I've got Fx, and I've got E. Okay, so we will, easiest one to solve is sum of forces in the x, because there's only one of those, equals 0. So we've got Fx minus 1,200 newtons, minus 1,200 newtons, because we've got 2 of those, equals 0. So Fx equals 2,400 newtons to the right. Okay, so let's go ahead and let's sum moments, because we can't really, and we'll do that around point F. Yeah, right? So we'll have E times its moment arm, which is going to be from here to here, which is 4 meters. Okay, and that's causing things to spin this way. So that's going to be a negative sign. Plus, now I got these two 1,200s. Each one of them is causing things to spin the other way around F. Right, so they're both going to have plus signs. So it's going to be 1,200 newtons times this one's 3 meters away, plus 1,200 newtons, and that other one is 6 meters away. Okay, so E equals, I think I just did this math, but let's just do it again. Yeah, it equals 1,200. I mean, excuse me, 2,700 newtons. Okay, so then we will need sum of the forces in the y. Okay, which you could probably do this in your head at this point. E is up, plus Fy is also up, right? So if E is 2,700, then Fy equals negative 2,700 newtons. Okay, cool. Right? Okay, so now we just need to pick a starting point. I'm going to start at A, because that's just where I choose to start. You could start in other locations. You could start at F, would be a pretty easy starting point. E won't work. Yeah, F or A are really the only two good starting points. I'm going to start with A. I'm going to follow my key. I could start at F if I wanted to, or somewhere else, but I think it's probably better to just, I'm going to have to so this is what it looks like. This is free body diagram of A. Okay, I like to assume compression. Here's AC. Here's AB. Okay, sum of the forces in the x equals 0. Sum of the forces in the y equals 0. So in the x direction, we only have negative AB equals 0. So AB equals 0. Boom. Okay, in the y direction, I've got AC plus nothing equals 0. So AC equals 0. Okay, so we're going to go down here. We'll say AB is 0, AC is 0. Boom. Beautiful. Okay, let's go to point B. Okay, well, let's see. So that gives us this one and this one. And now, if I go to point B, I've got 2 unknowns, so I can solve it. If I go to C, I've got 3 unknowns. 1, 2, 3, so I'm not going to go to C yet. So I'm going to go to B. Okay, so here's B. And B looks like this. Okay, so this is, again, let's go in blue. Right, you guys should know that, I don't really put a lot of energy into these particular types of free body diagrams. And then right here, there's no force. Okay, right, we just solved for that. So, I mean, you could put an arrow there if you wanted to, but I'm just going to put a 0. But we also have this external force. And when I was taking this class, that would have been the part that I would have forgotten. Okay, so we'll go sum of the forces in the x equals 0, and then sum of forces in the y. And we'll just have to figure out which one we're going to do first in a second. Okay, so in the x direction, we've only got one unknown. That's the BCX. Okay, so let's go ahead and do that. So we'll say we've got the negative 1,200 in the x direction. plus BC cosine of, now this angle, the angle with right here, if you do the inverse tangent of 3 over 4, you'll get 36.870 degrees. Okay, so that's the angle we're going to use. Again, I think it's easier. So like right now, I'm putting in the cosine of this angle. The other thing I could do is I could say, well, this is a 3 meters, 4 meters, and a 5 meters. So we got 4 and we got 3 meters, right? So if I want the cosine of this thing, well, I've got 4 over 5, right? So instead of using cosine of 36.870 degrees right here, I could use 4 over 5. I could just plug in 4 over 5 right there. Okay, that would be better and it would be more precise. Notice if you plug into your calculator, what is the cosine of 36.870? Well, notice it's 0.8, okay? And there's a reason for that, okay? But anyway, that is the quicker way to do it. Most of my students don't like that though. Okay, so if we solve this equation, we're going to end up with BC equals 1500.0 newtons. Okay, so now we're going to do sum of forces into Y. And let's see, so we've got 2 forces into Y. I've got BC times the sine of 36.870 degrees. Okay, plus BD equals 0. Okay, again, instead of sine, we could have done 3 over 5. It would have been more accurate. So in place of BC, I'm going to plug in 1500 newtons. In place of sine, just because I'm going to, you could plug in sine of 36.870 and you'll get 0.6. So I'm going to do it like this, equals 0. And so we end up with BD equals a negative number, negative 900.00 newtons. Okay, cool. All right, so BD is 900 in tension and BC is 1500 in compression. Okay, so BC is 1500 in compression and BD is 900 in tension. Okay, working our way along. Okay, so we now know BC and BD. Okay, so let's see here. BC we know. We now know BD. Okay, let's get rid of these little tick marks, which are not helping me. And let's get rid of this. Okay. Let's get rid of everything that's not really helpful. Okay, so now we can go to C or D. Notice if I go to D, I still have 3 unknowns there, so that's not going to work. So let's go to C, because we've got 2 unknowns there, C, D, and CE. So let's go to C. Looks like this is working out alphabetical. I don't remember if that's the way this whole thing works out. But here's C, right? So we've got this going down, get this thing off in an angle, get this one going this way, and we've got that one going that way. Okay, so I've got 1500 on this angle. I've got a big fat 0 on this one. Oh yeah, we're supposed to be doing this in blue. Blue, 1500 newtons. Got this arrow right here. I've got CD. I like to assume compression. And this is CE. Okay, so what's going to be easier, X or Y? Well, neither one of these is going to be particularly easier or any easier than the other. They've both got the same number of unknowns, and they both got 1 diagonal force on them, so it doesn't matter. So when it doesn't matter, I do X first because, I'm an alphabet guy, Okay, so in the X direction, let's see here. We've got negative CD minus 1500. 0.0 newtons, and remember that you guys like to do the cosine of that angle. We'll say the cosine of 36.870 degrees. 4 over 5 would have been better, but whatever. So CD is going to be a negative number here. It's going to be negative 1200 newtons. Okay, so CD is 1200 in tension. Okay, and then forces into Y, let's see here. We've got negative 1500 sine of 36.870 degrees plus CE. Plus CE equals 0. So CE equals, well, sine is 3/5 in this case, so that's going to be 900. So it's going to be a positive 900 newtons. Okay, so CE is in compression and CD is in tension. So CE is 900 that was positive, so that'll be compression. And CD was 1200 in tension. Oh, I'm forgetting units here. We're gonna check my units when this is all done. All right. Okay. Let's keep rolling. All right. So now we've got CD and CE. Let's see here. CD we've got. CE we've got. Okay. I can do D because there's two unknowns. I can do E because there's two unknowns. So I can go anywhere I want. Let's just keep going alphabetical because that's, I don't know. Why not? Okay. So here's D. And D looks a lot like C. It's just got tons of forces. It's got forces all over the place, right? And we've got 900 going up because that one was in tension. I've got, oh man, I always forget to do this. Let me do it in blue, baby. All right, let's see here. So we've got 900 newtons going up. I've got DF right here. Okay, I've got this 1200 over here. I've got DE on this angle right here. Okay, and I've got an external of 1200 newtons. Okay, so that external again is what I would have forgotten. All right, so here we go. We're going to go sum of the forces in the X equals 0. Sum of the forces in the Y equals 0. Okay, notice there's two unknowns in the Y, so we won't do that first. We'll do the X direction first. Okay, so I've got, let's see here, I've got negative 1200 newtons for this one. I've got minus another 1200 newtons for this one. And I've got plus DE times the cosine of 36.870 degrees equals 0. Now again, for that, I would use 4 over 5, but that's entirely up to you. So this becomes 1200, 2400, 5/4 of 2400 is 3,000, positive 3,000 newtons. Okay, so that means DC is in compression. Okay, and then we're going to go to the sum of the forces in the Y direction, and I've got 900 going up, plus DF, plus DE, times the sine of that angle, whatever that angle was, 36.870 degrees. I really prefer 3/5. And then, of course, we got to do one more step here because I got to plug in. DE is 3,000 newtons. I'm just going to write 3/5 here equals 0, right? So 1,800 and 900 is 2,700, so DF equals negative 2,700 newtons. Okay? Okay, so DF is in tension. Negative 2,700 in tension. And that. DC is 3,000 in those positive, so that'll be compression. All right, so I just got to get EF. So let's see if we go up here. I now know DE and I know DF. Okay. No, wait, I don't know DF. Do I know DF? Yeah, just solve DF. I need EF. Okay, so I can get EF at either location here. I can get it either at E or at F, and then I'll use the other location for just for checking. And so I think here what I would do, my inclination is, especially if I have time, is to do it at E and then use F as my check because F is really simple. But probably you should do F because F is a simpler location. So there's less chance that you'll screw it up. Less chance of like a careless error or whatever. But anyway, I'm just going to do E. You could have done different orders. It's not, Anyway, E. Okay, E looks like this. Okay, we've got 3,000 over here. We've got EF over here. All right, so let's go ahead and draw these guys. We got 900 coming down. We've got 3,000 going this way. We've got EF here. And I've got 2,700 right here. Okay, so again, let's see. Well, we only really need one of these things, right? So let's do sum of the forces in the x direction. The y direction force is just going to be a check, right? So that's really, we're just checking to see if that works. So here we go. The x direction, I've got negative EF minus 3,000 newtons times the cosine of that angle, 36.870 degrees equals 0, or 4/5. So 0.8 times 3,000 is 2,400. So EF equals negative 2,400 newtons. Well, there should be a 5 sig figs is the way I typically go. Okay, so EF is in tension. And then we're just going to check the vertical because this will be useful. We've got extra equations, so we might as well use them. So I've got negative 900 newtons. That's this one. Plus 2,700 newtons. Minus 3,000 newtons times the sine of that angle, 36.870 degrees equals 0. Right, and let's see. So this is 3/5. 3/5 of 3,000 is 1,800, and so this all works out. Check. Okay. The last thing you can do to check this. So wait, this is 2,400, and that will be in tension. I will note that this negative sign would be incorrect. You would definitely get points off for saying it is in negative tension, right? Because negative tension is compression. All right, so let's do another check here. Hopefully it's recording me. It looks like it's frozen. But we're going to do one more check, and I'm going to go down here. So if we look at this thing, where are we? Here we are. We now have everything, but let's go ahead and check F, right? Because if everything adds up at F, then we're in good shape. Okay, so here's joint F. And F actually, I think, is easy enough that you can just kind of look at it and see if it's, here's F. And see if it checks out. Okay, so we've got these two internal forces coming in there. I've got 2,700 going up. And I've got, 2,400 going, sorry. I drew that the wrong way, didn't I? So I've got 2,400 going this way. Okay, and then my external forces on it, Fx and Fy. Well, we had 2,400 going this way, and I had 2,700 going this way. Okay, so if you can just kind of visually do those. Do the forces in the x direction add up to 0? Yes, they do. Do the ones in the y direction add up to 0? Yes, they do. Okay, so you've got to double check. Okay, so we're going to check our units, and my units are not there. So newtons, 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 newtons. And really, since I asked for 3 sig figs, I'm not going to take off on this for people doing this because I feel like half the class is going to do this. But this should have been 1.50 kilonewtons in compression. This should have been 0.900 kilonewtons in tension. This should have been 1.20 kilonewtons in tension. 0.900 kilonewtons in compression. This should have been 3.00 kilonewtons in compression and 2.70 kilonewtons in tension and 2.40 kilonewtons in tension. Okay, so that would have been one way to do it. Another way you could have done it, like that gives that 3 sig figs, that gives that 3 sig figs. So for the smaller numbers. So the bigger one numbers, you're really going to have to you're going to have to go to like scientific notation or use the prefix kilo. All right, anyway, so that was an hour and 10 minutes of me like just working this sucker, working this one twice, the fast way and the slow way, and then, working number 2 twice. How am I going to grade this last one? Well, there's no way around it, this. There are basically 6 joints you have to do. Wait, let's see. There's 27 points. So interpretation of tensions and compressions, plus these other 2 up here. Those are 1 point each. Okay? And then basically what I'm looking at is your equations, right? So we've got, so that's what? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 of your 27 points. That's 18 more points. So basically, you've got 2 points for this equation, 2 points for this equation, and 2 points for this equation, right? Those are the biggies, right? So that's 6. So now we're up to 15. We've only got 12 more points. Well, look, we've got, these 6 locations, right? So we've got 2 equations here, 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 and we've got 2 equations here, right? 1, 2, 3, 4, 5, and then we got 2 equations here, okay? So basically with these last equations being, did you check your answer? Okay, so really this last 3 points from this equation and these 2 equations are your answers. Did you check your answers? Because you can check them. So if you get everything right here, I don't even need to look at your work, right? You get a plus 27. Was that how many this was worth? 27? Yeah, pretty straightforward, right? So anyway, if I had made this shorter, if I had made this a shorter exam, then basically you would have had 2 fewer joints. So that's how I would have done this. So anyway, so there you go. That's it. That's it. So I'm going to grade. And hopefully I'll get this to you by Monday or Tuesday. So have a good weekend and goodbye.